Hello everybody. I'm going to do another comparison between the old bifilar mag coil and the new bifilar mag coil. I had just finished of doing a PEMF comparison between these two coils. You can go look up on the web or the Aurora website, and you'll be able to see that video also. Here we go. I have a Spooky dedicated to the old mag, and I have a Spooky dedicated to the new bifilar coil. They're all connected up already. I have channel 1 connected to here on the scope, and this is a red line, and I have channel 2 connected to here, the yellow line on the scope. I have my gauze meter in the background. These right now are presently initialized to 1 kilohertz, 20 volts amplitude, no offset, 0 offset, 50% duty cycle, and no phase. And they're identical. Both channel 1 and channel 2 will track one another. I have them in sync, and the same thing here. So we're going to energize both coils when we do this presentation, and we'll do the same thing here. We'll energize both coils and with this Spooky here. And we'll show you the difference. This is what we want to notice. How strong is the magnetic wave pulse? I've already measured this. I'll do it again to validate that I'm pretty close. It's about 18 inches. It's about 18 inches. So both coils are about 18 inches away from the meter. That's 1.5 feet. And here we go with the test. I'll start off by energizing the mag coil. Make sure I'm set up to channel 1, and here we go. Okay, so right now, at 1,000 kilohertz, I'm getting a frequency of a little over 6. I'm looking at it a little skew, so it could be 6.5, could even be 7 milligauss. It's halfway deflection on the meter. The point that I want to really emphasize is the relative reading, and you'll see that in a second. I'm going to turn this one off, and I'm going to energize channel 2. I'll sync on channel 2, and you notice the meter's pegged. We went from 6 milligauss to well over 100, maybe 200 milligauss at 18 inches. Entirely no comparison, just no comparison whatsoever. I'll turn this on and off. I'm going to dive down in frequency. So we already know that this coil compared to the old mag is immensely, 10 times better, maybe even more than that. But we also want to check now the frequencies that these coils respond to. This one has a much broader frequency range that it'll respond to than the old mag. The old mag was a great coil, and it was relatively easy to wind and so forth. This is a little bit bigger, a lot more expensive in material cost, but it's just worth it. There's just no comparison between the two. And it took a little education to get there. I'm sorry I didn't start out with this coil right away. I had a friend out in Oregon named Peter who gave me the hint to start working with bigger coils and larger wire. So we did, and we just were astounded by the difference, just totally astounded. So here we go. We're going to change the frequency on this now on both of them to 500 kilohertz. Not 500 hertz. Excuse me. Let me restate that. So channel 1 frequency, and I'll drop it down to 500. It is now at 500. I'll do the same thing over here. Channel 1 frequency, drop it down to 500. They're both 500 now. Okay, let's do that same comparison. This time, because I already have the scope set for channel 2, watch the yellow one. That's this one, and we'll hit it go. And it's pegging the meter. 500 kilohertz is pegging the meter. Let's go take a look at the other one. I'll turn this one off. Change my sync. Oh, I hate when I do that. And we'll now start this one. And it's about 5. So we actually lost a milligauss on here. This one didn't even care between 500 hertz and a kilohertz. Let's go down to 100 hertz and see what the difference is. I'll stop this one, change the frequency to 100 hertz, channel 1 frequency, and dial it down to 100. It is there. I'll do the same thing here. Oops, excuse me. Channel 1 frequency down to 100. And that's there too. Now when I dial channel 1 here, because there's a setting that is preset to make channel 2 always follow channel 1, I did that inside. There's some controls you can do that with. I think I've demonstrated that in some other videos. Okay, let's because we're at channel 1, let's turn on this one and that. And it's running, and you can see now we're dropped down to about a little over 2.5, maybe 3. Turn it off, make sure I can see it deflect. Yeah, it's deflecting. Off, on, off, on, off. Let's switch to channel 2, and let's turn this baby on. This one right here. Not pegging the meter anymore, but it is over 100 gauss. It's not pegging the meter. So as you can see, as we go lower in frequency, this coil's losing a little response, this coil's losing a lot of response. But relative to where it was at 5, and that's before, it's really not that much. I can tell you already that this coil, and I'll do it, you can say go low. I know I can't go much lower than 10 hertz because it'll just get lost. It won't do a thing. All right, let's go down to channel 1 frequency, dial in 10 hertz. 10 hertz is done. Let's do the same thing here. Channel 1 frequency, dial in 10 hertz. 10 hertz is done. And okay, let's turn this one on. And you can see it flashing, and it is moving the meter, but barely moving the meter. Turn it off. Let's turn this one on. That's this one now, and it's barely moving. Did I do that right? Yeah, it's barely moving. So at 10 hertz, they both drop off pretty significantly. This is just a little stronger than that. Let's go the other way. We started out at 1 kilohertz. Let's go to 5 kilohertz. Let's start making some monumental jumps. So I'll turn them both off, and I will go to 5 kilohertz on, we'll call it the mag, the small mag, the older coil. Channel 1 frequency, and 5 kilohertz coming up. 5. Done. And let's dial the same thing over here. Channel 1 frequency, 5 kilohertz coming up. Done. Okay. We're syncing on channel 2 right now, so I'll start out with this one. I'll show you what this one does. Okay. It's no longer pegging the meter, so you can see we're falling off, but it's not. It's about, I'm going to say close to 25 milligauss. So the frequency has dropped off significantly, the energy or power has dropped off significantly when we got up to 5 kilohertz. But it's still giving a healthy signal. It's still doing a healthy magnetic wave. And this is off an unamplified spooky. I could increase the power here by running spooky into an amplifier, and I could get even more out of this, which will be for another video. I'm going to turn it off. I'm going to fire up channel 2. And you can see now we're doing about 5 milligauss. So this sort of stayed close to what it did at 500 hertz. 500 hertz to 5K or 5,000 hertz. It's giving me about 5 milligauss. Again, this is significantly better. Let's jump it up. Let's jump it up to 10. I'm just going to see how high we can go. Turn them. They're both off. Jump this one up to off. Get it off. There we go. Frequency. 10. It is now 10. Frequency, channel 1, frequency, it is now 10. Okay, let's look at this coil again first. Fire it up. And it's what, just a smidgen higher. It's still around 25 milligauss. It's not pegging the meter, but you can see it's significantly, it's getting close. Off, on, off, on. All right, let's turn it off and let's look at the other one. Okay, now we're down below 4, maybe real close to 4. So this one dropped off a little bit when we got up to 10 kilohertz. This one is still delivering a nice signal. Let me just change the sweep on the scope. And how about changing the sync too? Okay, so we change the sync, change the sweep. Okay, I'm going to go higher so those will scrunch up again. So here we are at 10,000. Let's go to 20,000. Let's just double it. So, and let's see what the difference is. Turn this one off and channel 1 frequency and 20. It is at now 20. Let's do the same thing here. Channel 1 frequency, and it is now both at 20. And I'm syncing on channel 1. Let's see. Let's turn this baby on right here. And this one starts losing it at around 20 kilohertz. Yeah, it is so little deflection. I'm looking on my computer. You can't notice the deflection. I can see a small deflection. So this one's out of the picture at 20 kilohertz. At this distance, by the way, I can move this closer and it's still there. We're leaving the, I'm not going to change the distance. I'll come back and I'll show you that if I had it closer, if you had the coil on, you believe me, there would be a nice hefty signal there. But at 18 inches, it's gone. Let's see what this one does at 18 inches. Turn it off. Turn this one on. And we're getting about 6 milligauss. And I can sync on that if I want. We're doing about 6 milligauss. So this one at 18 inches really gets pretty useless. This one is still going strong. Now, if I move this meter closer, let's go back to this old mag first. I'm turning this on. And let's move the meter closer. We're about a foot now and about 6 inches away. I don't know exactly. 8 inches away. About 8 inches away. And this BIfilar mag is still presenting a decent signal now at 8 inches away. Remember that the magnetic strength is proportional to the square of the distance. So if you do the math out, you'll see that if I get really on top of it, I'll peg the meter. In fact, I'll just move the meter. So, see, I'm pegging the meter. Okay. And that's because of the square of the distance law. And of course, if I turn this one off, what do you think is going to happen when I fire this baby up? Boom. It's going to be about 20. And of course, if I move this close, it's just going to peg the meter too. So I'll do it, and I'm pegging the meter. Okay. Pegging the meter. All right, so let's see if we can get up to about 30 kilohertz and still have some functional waves coming out of these two coils. I'll turn this one off and dial in 30. Channel 1, frequency 30. I'm there. Do the same thing here. Channel 1, frequency 30. I'm there. And what are we syncing on right now? We're syncing on channel 2, so let's fire this one up. Oops, I didn't turn it completely off. Okay. Okay, so we had to move it 8. We're 8 inches away, and we have a magnetic reading at 30 hertz of about 7 milligauss. And we'll do the same thing with this one. Turn this one off. Switch to channel 1 on the sync, and turn this baby up. And that's about 4 milligauss. So as you can see, the higher in frequency we go, the weaker the field gets. But there is still a significant field if I move the meter closer. Now, a lot of people, for example, my wife uses this coil right on top of her chest, so it's in contact with her except through her clothes. And you can do the same thing here. How high can you go? I'll jump it up to 50 kilohertz, and let's see what we have, and that'll be the last one I do. So here we go, 50 kilohertz, turn this off, frequency, channel 1, 50. Okay, and we'll do the same thing here, 50 kilohertz, channel 1, frequency, 50 kilohertz, and we're there. Okay, we're syncing on channel 1, let's turn it on. And there is a deflection. At 8 inches, there's a deflection. It deflects about 1. It deflects by 1 milligauss. And of course, again, it's the same thing. I could bring it closer, and it's a square of the distance, and I get it too close, and it's just going to peg the meter. And I'll turn this one off, and turn this one on. And this is about almost 3. You can see the deflection. And of course, you know, it's going to peg the meter again. Okay. Actually, the field is down, so I have to move the meter down. Just put it in. Yeah. Did you see that? I'm coming down, and I get in near the middle of the field, and it pegs the meter. Okay. That is a presentation making a basic comparison. I'll do one more video on these on this coil, on the BIfilar coils, just showing the various connections and how that's done, because I had this all pre-wired. Long video, 16 minutes. Sorry for that. Okay, I hope you enjoyed it.